Alright, boys and girls, this is the other half of the problems. These are the ones that say solve. So remember, if they say solve, your final answer is actually going to be, you're going to find out what x is. So first problem, number 1, I notice it's quadratic. I got to get it equal to 0. So I add 7x on both sides. That leaves me with 4x squared plus 7x, which equals 0. Now I got to factor that side. Well, it's a binomial that has a common factor. So I'm going to factor out the x, which is the greatest common factor between these two terms. I'm left with 4x plus 7, which equals 0. Now that I have a multiplication problem and it's factored, I can set both equal to 0. X equals 0 and 4x plus 7 equals 0 and solve both of them. This one's already solved for x. Now for this, I'm going to subtract 7, and then I'm going to divide by 4. And x is going to be equal to a negative 7 over 4, which you could have also done the decimal. Next one, same kind of problem. It's a quadratic because it's k squared, so I have to get it equal to 0. So I move the negative 10k over. But then I notice that it's not in descending order. So just to get it a little more clear for me, I'm going to put this in descending order. K squared is positive, negative 10k, and then the 24 is positive, which equals 0. And I notice it's one of those trinomials that looks like it's in the form, it is in the form of ax squared plus bx plus c. So what I'm going to do is I'm going to factor the c into the two terms, and you're looking for the two things that multiply to 24 but add to negative 10, and that would be negative 6 times negative 4. So my quadratic is going to factor into k minus 6 times k minus 4, which equals 0. And now that I have it factored and it equals 0, I can set each equal to 0, so I can solve for k. Add 6 to both sides, you end up with k equals 6. And the other answer, I got k minus 4 equals 0. So when I add 4 to both sides, I get my other answer of k equals 4. Next problem. So here's a problem where I notice right away, it's a quadratic, x squared. So I move the x over, and I'm going to, so I got to subtract x on both sides. I'm going to put that little minus x before the negative 20, so it's in descending order. Now I notice it's a trinomial that says x squared minus 1x minus 20. So this is one of those trinomials that I can factor by finding the factors of c that add to b. So the factors of negative 20, but they have to add to negative 1. So I'm going to use negative 5 and positive 4, because when you add those together, you get negative 1. And when you multiply those together, you get negative 20. So I could automatically factor into the two binomials with these as my two numbers inside, negative 5, positive 4, which equals 0. And last, now that I have it factored, I can set each of these equal to 0 and solve both of them. So I'm going to add 5 on both sides here, and I'm going to subtract 4 on both sides here. Next one, again it's a quadratic, so I'm going to have to be equal to 0. So I add 3x on both sides. Now this is not a trinomial, so I can't just find the factors that there is no a, b, and c. So, well, actually there is an a, there's a b, but there's no c. So this is one where I have to find the common factor, which is x, and it leaves me with 10x plus 3, which equals 0. Now I'm going to go through those steps. I have it factored, so now I can set both equal to 0. Already solved. I subtract 3 on both sides. I get 10x equals negative 3. Then I divide both sides by 10, and I get x equals negative 3 over 10, or negative 3/10. Okay, now, number 5. Right away, I notice that it's a quadratic. It already equals 0. So now I just have to factor this side. Now that's a binomial, so I'm going to look for the greatest common factor, which in this case is 9x. So I'm left with x minus 3, which equals 0, because I factored out the 9x, and that's what's left. Now, if you weren't sure that the 9x was the greatest common factor, if I did the prime factorization of each of these, I would have got 3 times 3 times x, and the other one I would have got 3 times 3 times x, and they each share 2 3's and 1 x. So you can see that the greatest common factor is 3 times x, which is 9x. Now that I have a multiplication problem, set each both equal to 0. Here I just divide by 9, and I get x equals 0. Here I'm going to add 3 to both sides, and I get x equals 3. Next one, it's already a quadratic, it already equals 0, so I just have to figure out what type of a quadratic is this. It's that trinomial in that form where the a is 1, and it's ax squared plus bx plus c. So I can just find the factors of -8, which add to +2, which would be 4 and -2. So I can factor it into d plus 4 times d minus 2, which again equals 0. And now set both each equal to 0. Solve both of them, and you end up, if you subtract 4 on both sides and add 2 on both sides, you get d equals -4 and d equals 2. Okay, number 7. First thing, you notice you have a quadratic. This one doesn't equal 0, so I have to add 54 to both sides in order to get it on the other side. And I get y squared minus 29y plus 54 equals 0. I notice I have one of those special trinomials, so I could just find the factors of 54. Well, when I start doing this, I know it has to add to a -29, so I'm looking for two negative numbers. Well, I know -9 and -6. But that doesn't add to -29. So now I'm kind of stumped. So I want to remind you that if you ever can't think of all the factors of 54, do the prime factorization. 54 would be 9 and 6, 3 and 2, 3 and 3. So the prime factorization is 2 times 3 times 3 times 3. Now if I take different combinations of these numbers, I'll find the factors. And remember, both of them have to be negative. So I could take all of those, 3 times 3 times 3, and get 27. And I get times 2. Well, actually, if they're both negative, that's it. -27 times -2 is positive 54, and you add them, you get -29. So I could factor into y minus 27 times y minus 2, which equals 0. And if I set both of them equal to 0 and solve them, I get my two answers, which would be I add 27 on both sides for that one. And for this one, I have to add 2 on both sides. Plus 2 plus 2, and I forgot to show my work, plus 27 plus 27. And there are my two answers, 27 and 2. Hope that helps. Please watch both videos again if you need to, and remember we have a quiz on Monday.